The blockchain revolution. What is a blockchain really? Imagine you and your friends share a notebook. Every time one of you makes a transaction, lending money, trading something, or recording an agreement, you write it down in the notebook. Now imagine that everyone has a copy of that notebook, and when someone adds a new line, everyone updates their copy at the same time. That, in essence, is what a blockchain does. It's a shared digital ledger, a system for recording information that is transparent, everyone can see it, permanent, once recorded, it can't easily changed. Decentralized, no one person controls it. Instead of existing on a single server, blockchain data lives on thousands of computers around the world, all keeping each other honest. The structure of a block. To understand blockchain, think of it as a chain made of blocks, digital containers of information. Each block includes a list of transactions, who sent what to whom, a timestamp, when it happened, a hash, a unique fingerprint created by cryptographic algorithm, the hash of the previous block connecting it securely to the chain. By linking every block to the one before it, the blockchain forms an immutable record. If someone tried to change even one transaction, it would break the entire chain, and everyone in the network would immediately know. Cryptography, the science of trust. At the heart of blockchain lies cryptography, the same science used to protect military communications and online passwords. Cryptography ensures that only the owner of digital assets can move them through the private keys. Transactions can't be faked or altered. Everyone can verify the information independently. There are two main cryptographic tools in blockchain: hashing and digital signatures. Hashing converts data into a fixed length code, like a fingerprint. Even the smallest change creates a completely different hash. Digital signatures verify who created or approved a transaction. Together, these tools create mathematical trust, the foundation of decentralized system. How the blockchain works. Let's break down what happens when you send a crypto transaction. You create a transaction using your digital wallet. The transaction is digitally signed with your private key. It's broadcast to the blockchain network. Note, check that your digital signature is valid and that you have enough balance. Verified transactions are grouped together into a block. The network reaches consensus agreement that the block is valid. The block is added to the blockchain, visible to everyone. This happens continuously, creating a living, breathing digital ledger that updates every few seconds or minutes. Consensus mechanisms. Without a central authority, how do thousands of computers agree on which transactions are valid? That's where consensus mechanisms come in. The rules that govern agreement. There are several methods, but two are the most common. First, proof of work, POW, used by Bitcoin and early cryptocurrencies. Miners compete to solve complex puzzles. The first to solve one earns the right to add the next block and receive a reward. It's secure but energy intensive. Second, proof of stake, POS, used by Ethereum and new blockchains. Instead of mining, users lock up stake their coins as a guarantee of honesty. Validators are randomly chosen to confirm blocks, earning rewards if they play fair. Other systems like delegated proof of stake and proof of authority exist for different networks, each balancing speed, decentralization, and security. Why blockchain is revolutionary? Blockchain is not just a new kind of database, it's a new kind of trust system. Traditionally, trust comes from institutions, banks, governments, notaries, or companies. In blockchain, trust comes from code, transparency, and collective verification. That's why blockchain is often called the Internet of Value. It allows people to exchange not just information, just ownership, securely, directly, and globally. This concept goes far beyond money. Beyond cryptocurrency, real world uses of blockchain. While Bitcoin introduced blockchain as digital cash, innovators soon realized it would transform many industries. Here are just a few examples. Finance and banking. instant cross-border payments without intermediaries, decentralized lending and borrowing, tokenized assets, stocks, bonds, or real estate on blockchain. Supply chain management, tracking products from factory to consumer with total transparency, preventing fraud in luxury goods, medicine, and food. Digital ownership, artists and creators can sell digital art or music directly as non-fungible tokens. Proof of ownership stored on the blockchain. Healthcare, securing patient data, prescriptions, and medical records in tamper-proof systems. Governance and voting, transparent digital voting systems that can't be altered. Community governance for decentralized projects, known as DAOs, or decentralized autonomous organizations. Blockchain is no longer just about crypto. It's about trust, transparency, and empowerment in every part of society. Smart contracts, the next evolution. One of blockchain's greatest inventions after Bitcoin is the smart contract. A smart contract is a piece of code that automatically executes when certain conditions are met, like a digital vending machine. For example, if Alice sends Bob 1 ETH and the deadline is before October 31st, then the system releases a digital asset to Alice automatically. No lawyers, no paperwork, no delays, just code executing agreements. Ethereum, launched in 2015, made smart contracts mainstream, allowing developers to build decentralized applications that run entirely on the blockchain. These apps have created entire ecosystems for finance, gaming, art, and identity, all powered by code. Limitations and challenges. Of course, blockchain is not perfect. It faces several real-world challenges. Scalability. Many blockchains can handle only a limited number of transactions per second. Energy consumption. Proof of work. A system like Bitcoin uses significant energy, though cleaner alternatives are growing. Regulation. Governments are still figuring out how to handle decentralized systems. User experience, managing keys, wallets, and security can be complex for beginners. But technology evolves fast, and developers worldwide are working on layer second solutions, sidechains, and energy efficient algorithms to overcome these limits. The social impact of blockchain. Blockchain is not just a technical revolution, it's a social tone. But the first time people in developing countries can store value securely without a bank. Entrepreneurs can raise funds globally without middlemen. Artists can sell directly to their audience. In short, blockchain redistributes power from institutions to individuals. It gives people ownership, transparency, and freedom, values long overdue in the digital age. The future of blockchain. We are still in the early chapters of blockchain history, just as the internet in 1990s connected information. Blockchain in 2020s is connecting value. Future development may include governments launching digital currencies built on blockchain, entire economies running on smart contracts, identity, property, and citizenship records securely on decentralized networks. The world is moving from the Internet of Information to the Internet of Value, and blockchain is the bridge.